Hello everyone. In this video I'm going to talk about the capabilities of pSeven for remote execution. First of all, there are three ways how pSeven can be used for remote execution of different software. The first one is pSeven Agent, which I'm going to talk about in this video. It is used for remote execution on Windows and Linux machines. Then there is an SSH protocol for remote execution on Linux machines only. And then there are interfaces to Slurm, LSF and Torque job managers for remote execution on high-performance computing servers and clusters. Speaking about pSeven Agent, it's a simple standalone software tool that allows remote execution of different software, including CAD and CAE systems on remote Windows and Linux machines, as I said. The connection to pSeven Agent is available only through program block, and it comes together with the pSeven installation package, and it is also available as a separate installer on our website. By the way, to use pSeven Agent correctly, the system administrator must allow the external connection to the Python executable in the installation folder, so please keep that in mind. To showcase the capabilities of pSeven Agent, I'm going to use a modified example from pSeven. It's a structural analysis of rotating disk in ANSYS Mechanical PDL. The workflow is run on a local Windows machine. First, the user inputs the rotating speed. Then the text block generates an input APDL file. Then the program block sends this input file and the files from a local sandbox to the remote Windows machine where the pSeven Agent is started, and also ANSYS Mechanical PDL is installed because it is necessary for executing the file. After the simulation is finished, pSeven Agent sends the output file back to program block, and it sends it to the final text block that parses the results and gives the outputs. Let's proceed to pSeven. Here we have the preset workflow. As an input, it takes the rotational speed in RPM that is transferred via a link to the text block that generates an APDL file. This macros reads in an external geometry file from Parasolid. It's called rotating disk. We'll get back to it later. Then the text block goes to the program block. Here in the settings we have different variants of remote execution. Now the pSeven Agent variant is chosen. The settings of pSeven Agent really simple. First of all, you have to define the host name, then the port that will be used for remote execution, and the authentication token. Let's name it pSeven. Then there's an option for working directory synchronization. It is used to send the files from the local working directory to the remote. In this block, I use a sandbox or a working directory with this address. The geometry, the Parasolid geometry, is situated there. So when I start the block, the file will be transferred to the remote machine where the executed macros will read it and go on with the simulation. So to use pSeven Agent, you need to run it on the remote computer. Let's use the remote desktop connection. This is the host that I'm going to use. Let's open the pSeven Agent. In the configuration, let's check that the port is the same as in the program block, and we use the same token, pSeven. Okay, let's start the pSeven Agent. As you can see, it's really simple, just one button here. Then let's return to program block and test the connection. So we were able to connect to the remote computer. Okay, after the simulation is finished, the output file will be returned to the program block and then transferred to the last text block that will parse the results and give us the outputs. Let's go to the Run tab. Let's change the rotational speed to, for example, 12,000. Okay, and let's run the workflow. So the run was successful and we got the predefined results. This scheme can be used in any other workflow. You can add different optimization tools, design of experiment tools, and you can create as complicated workflow as you need. And the program block will be there for you to save computational time on your local computer and use your company's clusters, servers, and other HPC hardware. So we hope that this will be useful for our users. And this concludes the video. Thank you and goodbye.